Hi there. Today we're going to look at exponential and logarithmic equations. So everything we've been doing up to this point has been getting us ready for today's lesson. Actually being able to use these properties and to be able to solve an equation. So to begin with, let's look at a few properties that we'll need. One of them is an exponential one-to-one property, which basically says that if you have an exponent equal, or an exponential kind of situation, equal to another exponential situation, as long as these bases here are the same, the only way that this equation could be equal is if your two exponents were also the same. Okay, so what we'll do is we'll look and see if we can get it to be an exponential on both sides with this same base. Then we can ditch the base and just work on the u and the v, or the exponents, and make them equal to each other. Okay, so let's try this first example that's going to be like that. Now, I know that I have an exponential situation because my x is caught up here as an exponent. And so just like anytime you solve for x, you try to start to isolate that. So our first step would be that to get rid of this 20 that's being multiplied, we can divide both sides by 20. Okay, so then we have a 1/2 to the x over 3 equals a 5/20 reduced to of 1/4. Now I like that because as we've practiced this more and more, we should start to recognize things that go together nicely. And 2's go together nicely with 4's, because I could rewrite that 4 as a 2 squared. All right, so really a 1/4 is a 1/2 squared. So I'm going to write this, not change that side, but over here this 1/4, I'm going to write it as a 1/2 squared. And the reason that I benefit in that way is because I've managed to get my bases to be the same here, just like up here when I had the b's were the same. The bases are the same. The only way these two sides can be equal to each other is if their exponents are equal to each other. So that's what I do. I forget about the 1/2 and I just make the exponents equal to each other. All right, so then x is equal to 6. So that's a one-to-one property. If you have one exponential equal to another exponential, that's what we're going to look to try to do. All right, here's another one-to-one property, but it has to do with logs. So if you'll notice here that you have a log base b, meaning any base that you want it to be, of something equals log base b of something else. Well, the only way that these two logs could be equal to each other is if that value that we're taking the log of, if those are equal to each other. So we'll kind of do the same thing. If we've got a log equals a log, we'll forget about the logs and just set the u and the v equal to each other and see what needs to happen. Okay, so let's look at this example. Now we are going to be pulling in some of that same stuff that we've been learning in the past, those properties we learned yesterday, the switching between logarithms and exponentials, evaluating, all of that stuff is going to tie in to solving. And so when I look at this one, I look and see a whole lot of stuff going on right here that needs to simplify. This one-to-one property only works if you have one log equal to one log. I have a couple logs going on over here. So what I'm going to do is use my properties from yesterday to kind of condense that into a single log. So there's a couple things that I see here that I can do. This 2 right here that's being multiplied, remember that can go up as an exponent, so I will do that. And then also I see a subtraction, and remember that can be converted back into division with a single log. So here's my condensing then, I think. I've got a natural log, and on top I'm going to have an x plus 6, and because of the minus sign I'm going to be dividing, and I'm going to have a 5, and I'm going to put that 2 up as an exponent. Okay, so I've managed to condense that to a single log, which is going to help me here because now I have a log equals a log. And the only way these two logs can equal each other is if these values will equal each other. So I'm going to set those equal to each other. So I have x plus 6 over, let's go ahead and square that 5, and it would have to equal 10. And then it just becomes a little algebra problem. You don't have exponential or logs left. You just do a little bit of algebra. So I've got x plus 6 equals 250. Subtract the 6, and I'm going to have 244 is my answer for that. All right, so those are the one-to-one properties. If you can have an exponential equal to an exponential, or if you can have a log equal to a log, that's when we're going to use our one-to-one properties. So what I'm going to do here is just practice solving a bunch of equations. And so we're going to use the one-to-one properties as necessary, or sometimes you're just going to do the converting forms that we have done previously to help you solve. So let's look at this first example. When I look at this, I see that there's an exponential going on here, but I only see it on the left side. I don't see an exponential over here anywhere. So I'm not sure that this is going to be a one-to-one situation. So let's work on it. Just try to start isolating that x. So the first thing we should be doing here is moving that 3 to the other side. And then we should undo that multiplication, so let's divide by 2. So I have e to the negative x equals, and I'm probably going to go ahead and go decimal on that. That'd be 1.5. Okay, and then I kind of get stumped here because I can't really get that x out of my exponential. And so when you get to the point where you've kind of isolated it as best you could, then that's when you go switch forms. We've practiced this where you have an exponential. Let's switch this to a logarithm. Okay, so at this stage right here is when we switch forms. It's a base e, so that would be a natural log of 1.5 equals my exponent. Okay, well this natural log of 1.5 is just something I can type in my calculator, and I'm just going to divide it by a -1. So when I type the natural log of 1.5 in my calculator, I get a 0.405, but since I'm dividing it by a negative, I'm going to end up with x equaling -0.405. And that's my answer. All right, let's try another one. Okay, on this next problem, I see a logarithm. But again, I only see the logarithm on the left side. I don't have it over here. So it's not going to be a one-to-one property where you have a log equals a log. So instead, I'm probably at some point going to be switching forms. But the one thing I do see from yesterday is this 3. Remember how that exponent can be pulled out in front? And I think that would be nice to bring that power out in front. So let's go ahead and do that. So then I'll have a 3 log x equals 6. And then now that it's being multiplied, I could get rid of it. And then I'm sort of stumped because I've got my log here. There's nothing else to get rid of. And so I'm going to switch forms. Now notice here that this log doesn't have a base number, and when it doesn't have a base number, it's called common log, and it's assumed to be a little 10 as your base number. So let's go do that loop thing, and let's go switch forms. So we've got 10 to the second equals x. Okay, and that's quick and easy then. 10 squared is just a 100. All right. What I'd like you to do is try this next one. It's somewhat similar to what we did where you have the log on just one side, so you'll have to do the switching forms thing. Go ahead and pause the video and give this one a try on your own. All right, so on this problem, you should have done the switch forms thing where you do 4 to the -1 equals x minus 5. And then let's go ahead and get rid of that -1 exponent. Remember, a negative exponent bumps it to the denominator. And so then your last step on this would just be to add the 5 to the other side. So a 1/4 plus a 5, you could just write it as 5 1/4, or you could go decimal, however you want. And that's your answer. All right, so let's try some more here. I have that you practice, but I'll kind of walk you through a couple of them here to help. So on this first one, I look at what scenario do I have, and what's different here is I do have a log equals a log. So this looks like more like one of my one-to-one properties, where if you have the log of 3x equals the log of x minus 5, the only way that's going to work is if 3x is equal to x minus 5. And once you get rid of the logs, it's just a simple little algebra equation. So x is going to be equal to a negative 5/2. All right, look at this next one. I see an exponential on this one. I don't see an exponential on this side though, so I don't think it'll be the one-to-one. I think it's going to be more the one where I have to switch forms. But before you switch forms, you always want to isolate as best you can. So you should be adding 8 to the other side. Okay, and then that's about all the isolating I can do. The only way to get this x out of this exponent thing would be to switch it to a logarithm. So this is going to be a logarithm that has a base e, so that's natural log, of 30 equals my exponent. Okay, well that worked very nicely to get the x out of there, and now I just have x equals natural log of 30, which is something I can just type in my calculator. Natural log of 30 is 3.4. Okay, next problem. Again, I'm going to have you try this one on your own. It looks like we've got some exponential business up here. The variable's in the exponent, but it's not on this side. So start isolating and then switch forms. Go ahead and pause the video. Okay, so hopefully you pretty easily got to this point where you were just moving the 4 and the 2 and got to this stage, and then you kind of get to this point where you're kind of stumped. Now, sometimes what people want to do is like divide both sides by 3, but you can't divide by 3 because that's not being multiplied right here. This is being raised to a power, and so don't try to like divide both sides by 3. That doesn't work. What you have to do when you get to that point is switch forms. It's an exponential. You got this t caught up here as your exponent, and so to get it out of there, you switch it to a logarithm. So when you switch it to a logarithm, it's going to be a log base 3 of 7.5 equals your exponent. And that manages to get your t out of the exponent, and it's just a matter of isolating it and adding the 5 and dividing by the 2. Now, I know that that's what I'm going to need to do, but let's talk about this side over here, because that's a little bit weird. But remember, now on our calculator we can do common log and we can do natural log, but we don't have a base 3 button on our calculator, so we typically will use our change of base formula. Remember that from yesterday? You'll take log of this bigger number divided by log of this little base number, and that's how we evaluate logs that have bases other than 10 or e. Okay, so let's do that in our calculator. So we'll take log of 7.5, don't forget to close your parenthesis there, and then divide by log of 3. And what we end up with is a 1.83. All right, I'm kind of out of room there, but from that stage you should add your 5 to the other side, and then you should divide by the 2, and then you'll have the t by itself. And if I do that, I'm going to end up with an answer of 3.42. And so final answer, t should equal 3.42. So we've dealt here with a lot of different types of equations to solve. And so always be looking to either do one-to-one properties or convert between exponentials and logarithms to help you solve. Let's look at somewhere that are some application type. So this kind of takes us back to doing some of our formula stuff that we had done previously. It says I deposited $500 in an account. It pays 6.75% interest. It's compounded continuously. So that tells you right there that you're going to be using your continuous compound formula, that PERT formula. And the question is, how long will it take to double my money? Okay, so let's start off and refresh our memory on that formula. So that's just going to be an A equals P is your principal, the money you invest, times E to the RT. Okay, so it says that I deposited $500. So that's going to be my P. So I know I'm going to have a 500 times E is just a number to the RT. R is your interest rate, always as a decimal. And then the time. Oh, that's actually the question. How long will it take? So I'm actually looking for the T. We never did that before. They always told us the time. But this time what they tell us is that we're trying to double our money. So what that means is my ending result, well, if I started with 500, I'm going to end up with 1,000 if I'm trying to double my money. And I'm going to then solve for T and find out how long it's going to take for that to happen. Okay, and now we've got this nice little equation like what we were solving earlier. Try to isolate that T. So your first step will be to divide by the 500. So the 500 goes away. 1,000 divided by 500 is 2, which equals E to the 0.0675 T. And we've kind of isolated that as best we can. So now we're ready to switch forms. Since it's a base E, I'll have a natural log of 2 equals my exponent. And so the natural log of 2 is something I just type in my calculator, and I'm going to divide both sides by 0.0675. So natural log of 2 divided by, don't forget to close that parenthesis, and we end up with T equaling 10.3. And if you look at that, remember T is your time, and it's measured in years when you're doing this compound continuous formula. So it's 10.3 years is how long it's going to take me to double my money. Okay, so something to think about here that I think is kind of interesting is we started with $500, and so it took us a little over 10 years to turn it into $1,000. Look at this little side note over here. You don't have to write this in your notes, but if you think about it, what if you only had $5 when you started? And then you did the rest of this. And how much would you end up with at the end? If you're trying to double your money, you'd end up with 10. And look at how similar this works out. You divide both sides by 5, and so you have 2 equals E to the 0.0675 T, and you are actually at the same place right here. So it doesn't really matter if you start with $5 or $500. It's still going to take you 10.3 years to double your money. So in our first scenario, we made quite a bit of money by doubling it. Here, we only went from $5 to $10. Still takes the same amount of time, though. All right, let's try one more problem here. So sometimes we have to use formulas that we have learned throughout the chapter. Other times, they just hand you the formula. And the trick is trying to be able to calculate that in your calculator and get all your parentheses correct and all of that. So in this case, it says the demand equation for a certain product is blah, 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 blah. Okay, so the demand is the X value, how much in need that product is, and P is going to be the price of it. So kind of in general, probably as your price increases, the demand is probably going to decrease a little bit. Not everything would be that case, but if you think about it, the more expensive it is, it's probably not as available to people, and so the demand would go down. Okay, so let's try this. It says, find the demand X if the price is 600. So here we go. I'm going to have 600 equals 5,000. this. Okay, big long formula here. And what we're trying to do is solve for this x right here. And so that's just buried in this problem here. And so we just have to little by little work at isolating that x. So the first thing I'm going to do, since I'm multiplying by 5,000, I'm going to divide both sides times 5,000 to get that out of there. Okay, so when I divide 600 by 5,000, I get 0.12. Okay, so now I have 1 minus, and this big long thing, and I'm going to be kind of lazy here and not write at that time. I'm also going to be running short of space, I think. So what I see then is probably wanting to get rid of this 1 that I have going on. Okay, let me erase that. That's probably going to be a little bit confusing. I'm going to go ahead and write it out. So it's 1 minus 4 over 4 plus e to the negative 0.002x. Okay, so I'm going to get rid of this 1, so I'm going to subtract 1 on both sides. So a 0.12 minus 1 gets us a negative 0.88. And what I have left here is this negative is still sitting here. And then I'll have this. All right, and I'm probably going to want to get rid of that negative right there, and I can just do that real quick. If I just divide both sides by a -1, that's going to turn that to a positive. It also turns that to a positive. So I've managed to get rid of that negative. And then the next thing I have is this whole thing in the denominator that I need to get out of the denominator. So I'm going to take both sides times that big mess. And so I got to take it this side times that big mess also. And so what I'm going to end up with, I'm going to change colors here so it doesn't get too cluttery. So I'm going to have the 0.88 times the big mess, 4 plus e to the negative 0.0026, or 2x. And that's going to be equal to 4. All right. Now I managed to get rid of the fraction. That was very beneficial to be rid of that fraction. So now start isolating again. Get rid of that 0.88. So 4 plus e to the negative 0.002x equals, and 4 divided by 0.88 gets me a 4.54, or 55. I'm going to subtract the 4, just isolating here. And at this stage right here, I kind of am stumped. I'm ready to probably switch forms at this stage. So here we go. Since it's a base e, I'm going to have natural log of 0.55 equals negative 0.002x. So to get the x by itself, I just need to divide by the negative 0.002. And what I'm going to be doing is taking the natural log of 0.55 in my calculator. So natural log 0.55, close the parenthesis, and divide it by the negative 0.002. So in the end, what I have for my x value, I have x equal to 298.92. All right, so it starts off and it's not a big deal because, you know, they give you everything you need, they give you the formula, but trying to get that x by itself takes a lot of algebra, so it's a good practice with our algebra skills. All right, you need to try this again. I just did that one for you. So now you do it again, and you do it with the price of 400. See if you can kind of work through it without peeking too much back at this problem we just did, and try it on your own. All right, so here's my answer on this problem. Pretty much the same deal as the last one. You just threw a 400 in there instead of a 600. I got a 524.91. All right, so we'll do most of your lesson is just practice the solving basic equations, and then towards the end I throw a few of these types of problems in, and we'll be doing more and more of these. So be sure that you work through those in your homework. Good luck.